Now our next article or next question is related to the differentiation of implicit relation. As we know from chapter number 1, and now this is again a little bit simplification of implicit relation, that when sometimes the functional relation is not explicitly expressed in the form of y is equal to f of x. That means, as we discussed in exercise 2.3 or question number 1 in exercise 2.4, that we have y is equal to some function of x like square root a plus x over a minus x, or y is equal to 6x square plus 2x. So we have actually explicitly defined function y is equal to some function of x. But an equation involving x and y is given. Now we actually not explicitly defined y is equal to f of x, and we have only an equation containing x and y. To find derivative dy by dx from such an equation, we differentiate each term of the equation and use the chain rule where it is required. The process of finding dy by dx in this process is called implicit differentiation. In simple words, you can say that we have not like a function which is y is equal to square root x plus square root x, and or y is equal to square root a plus x divided by a minus x. In both of these two examples, y is explicitly defined in terms of x, which is actually function of x. Or in this case, y is also explicitly defined a plus x, a minus x. But now in question number 2, there is no y in terms of x like this one, but an equation is given. As we mentioned here, an equation involving x and y is there. So we explained this process of finding dy by dx of such a implicit relation by using some question of question number 2. So question number 2, find dy by dx. This one is 3x plus 4y plus 7 is equal to 0. We have to find dy by dx. An easy example of implicit differentiation. There is no y in terms of x, or y is not defined explicitly in terms of x. So in some cases we use our chain rule or simply define dy by dx. Solution: given that 3x plus 4y plus 7 is equal to 0, differentiate with respect to x. So we apply derivative that is actually of the form 3. Derivative dy by dx will apply on x plus 4. Derivative will apply on y plus d by dx, or derivative will apply on 7, is equal to 0. So by solving this one, 3 will be as it is and derivative of x will be 1, plus 4 dy by dx will be as it is, which actually we have to calculate, and derivative of 7 will become 0. Now simple using algebraic technique to finding this dy by dx. When we apply this, 3 will be shifted to the right hand side, so this will be like this: 3 plus 4 dy by dx is equal to 0, and 4 dy by dx is equal to minus 3, and finally dy by dx will become minus 3 by 4. So this one is an easy question or easy exercise to define derivative of explicit relation in which y is not explicitly defined in terms of x, but there is an equation. Actually this one is an equation containing x and y, both variables. So we simply differentiate whole of this term, whole of this equation, and finally we will get dy by dx. Part 2, xy plus y square is equal to 2. Again we have to calculate dy by dx, and again you can see that there is no y in terms of x. There is no explicitly defined of value y in terms of x. So this one is actually example of implicit differentiation again. Given that xy plus y square is equal to 2, differentiate with respect to x. applying derivative separately on these three terms actually, on xy plus derivative on y square, and derivative will apply on 2. So d by dx will apply on xy, and d by dx will apply on y square, and d by dx will apply on 2. This is actually our product theorem when we apply derivative on xy. Our product theorem was derivative will apply on one by one both of these terms. So derivative first apply on x and y will be as it is, plus derivative will apply on y and x will be as it is, plus then we apply derivative on y square. So using our power theorem, this will become 2y 2 minus 1, and then derivative will apply on inner function which is y, so that will become dy by dx, and on right hand side derivative of a constant function will become 0. So derivative of x will be 1 into y, and derivative of y will be dy by dx, x will be as it is, and this is 2y, and dy by dx will be as it is, and on right hand side is equal to 0. So that is actually y into 1 will become y plus x dy by dx plus 2y dy by dx. So now we have actually to find dy by dx which is in both of these two terms. So again, using same algebraic technique, when we have to find a value of x, a simple example like x plus 3xy is equal to 2, then if we want to calculate the value of x, then we can take common x, that will be 1 plus 3y is equal to 2, and then finally value of x will become 2 divided by 1 plus 3y. So in simple algebra, if we want to calculate the value of a variable, like in this example we have to calculate the value of x, so on left hand side there should be simple x, and all other terms or all other data will be shifted towards right hand side. So again, using the same technique here, first we shift this y towards right hand side, that will become minus y, and then taking common dy by dx from these two terms, so finally we will calculate dy by dx in using the same procedure, that is y plus x plus 2y by taking common this dy by dx, that is equal to right hand side which is 0. Now dy by dx is x plus 2y is equal to, this y will be shifted towards right side, that will become minus y, and to find dy by dx, this x plus 2y will also be shifted towards right side. So as this one is multiplying by dy by dx, when we shift towards right hand side, this will be divided by minus y. So finally we have dy by dx is equal to minus y whole divided by x plus 2y, which is our required and final result. So again, using the same process or same implicit differentiation solution, given that x square minus 4xy minus 5y is equal to 0, there is no y which is explicitly defined in terms of x. Again, a simple equation containing both x and y. So differentiate with respect to x, differentiate or derivative will apply on x square, on xy, and 5y, right side will become 0. So derivative of x square will be 2x, and from here derivative will apply on xy, which is exactly the same as we discussed in our previous step. So this is actually derivative of xy, and from here 5 dy by dx is equal to 0. So this one is actually x dy by dx 1 into y, and applying 4 to both sides, 4x dy by dx, this y after multiplying by 4, that will be minus 4y when we shift towards right hand side. This is actually 2x minus 4x dy by dx minus 4y minus 5 dy by dx is equal to 0. We have to find derivative or dy by dx which is in two terms like this and this. First we shifted it to the right hand side so that this will become a positive thing, minus 4x dy by dx and minus 5 dy by dx towards right hand side, that will become a positive thing, 4x dy by dx plus 5 dy by dx. And on left hand side, 2x, and this one is without dy by dx, so 2x minus 4y, which is this one. So now we take common dy by dx from these two terms, that will become 4x plus 5, and on right hand side 2x minus 4y. And dy by dx, this 4x plus 5 as multiplied by dy by dx, by shifting towards right side, this will divided by 2x minus 4y, so this will actually be the required result. So that is 4x plus 5 dy by dx is equal to 2x minus 4y. And to find the value of dy by dx, this 4x plus 5 will be shifted to the right hand side. So this is actually multiplying by dy by dx. When we shift towards right hand side, this will be divided by 2x minus 4y. So that is actually our final result of dy by dx.